The future of construction is already sitting here, and the future of construction is also not working without knowing, looking back where we are coming from. So, do you have Katrin this pointer? It's here. Thank you. Now it works, yeah. So, for me, it's always important not to step back, but to look back. And here you see two ancient buildings, and in pre-industrial times, natural materials form the basis for construction, and structures also have represented always the state of our cultural development. So both buildings here represent, for their respective epoch, the unity of material, process, and form. And so this was for a long time, but then with industrialization, we got new materials, and new materials also required that known notions of design, processing, and form had to be reinvented. And getting knowledge of material, process, and form is a process of development, as you see here with the first bridge in Coldbrookdale, whose form was still of a stone bridge, but without stones. Infrastructure construction was then the birth of civil engineering, and the materials, steel and concrete, became the drivers of innovation in construction within the industrial age. Continuous research and development gradually resulted in formally impressive and structurally efficient concrete bridges like here, the first Forth Bridge in Scotland, or the Salgena-Tobel Bridge in Switzerland. With the new logic of form and with the new disciplines also came disciplinary views on design. And here you see the two iconic buildings from the 1950s, from Le Corbusier and from Felix Candela. And you see that both represent completely different ideas from the engineering and architectural point of view, how you design with concrete. So one is really efficient, minimized, efficient concrete structure. The other one is much more coming from a spatial idea how material could be arranged. Pierluigi Nervi overcame disciplinary thinking and brought together architecture, engineering, and processing by using these prefabricated lost formwork elements to build the roof of the Palazzetto dello Sport in just 30 days. Already end of the 19th century, in steel construction, the standardized series production of profiles started to determine the forms and construction methods, as well as the design and joining of the components, like you see here. As a consequence, steel design today is more a geometric planning than material-efficient forming. And with the beginning of the 20th century, in concrete construction, the two-dimensional system formwork and the planar reinforcement grids started to limit the geometric form and material efficiency. So the resulting mass-intensive geometrical plane structures still shape our idea of concrete buildings today. As a result, industrialization has led to open material flows in construction, and is now a major contributor to today's environmental impact. Niklas Mark, a writer for the Frankfurt Allgemeine Sonntagszeitung, he wrote in an article about the paradox of building in times of climate change. So he's addressing the fact that also the construction sector, like we heard before also from the minister, is responsible for around 50% of the world's resource consumption and around 11% of CO2 emissions. But we need to keep on going with construction in building as well in infrastructure. So the question of the future is how we can build for more people with less material and fewer emissions. And this is really dramatically, keep this always in your mind, just 80 years coming from 2.5 billion to 8 billion people where we are now. 80 years. At the transition from the industrial to the digital age, we need a new logic of form that is much more based on the convergence of material and manufacturing processes and uses the possibilities of digital tools with the goal of circularity. So in my opinion, this process, this renewal of the logic of form, is itself a process, like at the beginning of the industrial age. And it already began decades ago with the realization of such fantastic buildings like the Guggenheim Museum in Bilbao. Norman already mentioned that I had the luck at the turn of the millennium to be a project leader at the office of Bollinger & Kroman and was involved in the realization of these unique freeform architectures. Our question at that time was always, how do we get the industrial semi-finished products in those forms delivered by the architects? And also digitalization was also in that time the key for this. But we were producing also a lot of waste, and the processes were, of course, anything but economical. But finally, they opened my door to digitalization and are the basis up to today of my knowledge. So, where we have to go, I think what is really important that in digital age, we are clear that data are the key. Data are the basis for circularity, and they get controlled by soft and hardware. And in the software area, we already, there is a lot of ongoing innovation. We heard BIM, building information modeling, but also in the facility management. So in design and facility management, there is a lot of ongoing things. But we lack really here on the construction side with our traditional technologies, and also here in the question how we deconstruct our buildings. And those are the two major topics where we have to really invent new technologies. There's less time now, just 15 minutes, so I will focus on a concept how we have to build new, because I'm also convinced we have to build new. But important is also how we reuse and recycle the materials we have already in the existing building stock. So now 20 years later, after this period of freeform architecture, in my opinion, the technology of additive manufacturing offers a paradigm shift in construction. Why? Because here you can see first additive manufacturing is a layer-by-layer build-up of the components in a three-dimensional way. So we don't need forework, and also industrial pre-processes or complex adaptation of semi-finished products like we had in the freeform architectures are not required. So material and manufacturing process form a unit. And second, additive manufacturing processes are digitally controlled. That means they are enabled to get connected by data with design, facility management, so you can integrate in this whole thinking on digitalization in a circular economy. And third, we have the freedom of form with additive manufacturing to create new scope for this kind of renewing the logic of form. TU Braunschweig and TU Munich already recognized the signs of the times at an early stage, and with the TRR 277, we started with the beginning of 2020 to fundamentally research the technology of additive manufacturing in construction across materials and processes. 29 project leaders are researching the relationship between material, processes, and form in 18 projects. All individual projects are very experimental in their methodology and require highly interdisciplinary collaboration between scientists from civil engineering, mechanical engineering, and also architecture. Please feel invited to join our closing conference of the first funding period from the 9th to 11th October at TU Braunschweig. You can be there in presence, it's for free, or also it will be broadcasted via Zoom. Maybe we can reduce the noise a little bit, sorry. So there is not enough time to go in all the activities in the TRR, but I like to present some of the things, especially those ones we do at the ITE. So since 2016, we are continuously developing the so-called shotcrete 3D printing method, a deposition method, where the matrix is accelerated just before the nozzle by adding compressed air and admixtures. So this two-component process creates a very good bond across the layers and enables the imprinting, like you see here, of the reinforcement. Here you can see some of the form-optimized components in a one-to-one scale, which we have manufactured with a degree of freedom of the robotic facility. You will find them also well published. There is something not working. Okay. One crucial point for the efficiency of load-bearing components is, of course, reinforcement integration. Here, through combined automated processes of 3D printing and reinforcement integration, completely new strategies are possible, like you see here, maybe if you turn your head, the insertion of short rebars. Yeah, and of course, the efficiency from an engineering point of view lies in the merging of design and manufacturing as an interactive process. So here you can see the possibility of arranging the reinforcement along the tensile force lines by matching the concrete paths to the reinforcement integration. But for us also it is very important not just to focus on the small details in fundamental research. For us it's also important to look for applications where a new logic of form is ideally suited. We can of course print 3D print houses, but the 3D printed houses are 3D printed houses, and they are not, in terms of the possibility what 3D printing can do, a logic of form, a new logic of form. So this we have to really aiming for. And for example, in coastal protection, highly individualized shaping and material grading is able to base on local conditions and wave dynamics the energy to dissipate, and not just working as resistance by putting masses there, like we do now. So this is a mind gap in thinking. And also, 3D printing with concrete does not mean by itself just to think in terms of area and volumes. At the TU Braunschweig, together the ITE with IBM, the Kloft, we have recently also developed a completely new 3D printing process for concrete, where we put the matrix into a fluid in a dimensionally stable manner, making particularly filigrane concrete such as possible. The shown lightweight bridge here on the left, also in cooperation with Pierluigi and Ole Olbrock, gives the first impression of our research on the merging of material process and ingenious design. It's now exhibited at the Biennale in Venice. Our idea of integrating AMC is not simply replace traditional manufacturing. It is also about combining the advantages of serious production and additive manufacturing in hybrid manufacturing processes. Here you see an 8 centimeter thick slab, which is concreted, and on top printed fresh just ribs. And if you compare the masses with the standard, normally what we build today, 30 centimeters thick flat slab, you can save 60% of the concrete masses, just by rethinking what we are doing and try to find new ideas to make structures efficient. The same you can do in steel construction. Here we are exploring hybrid fabrication for structural steelwork by locally strengthening the standard profiles. This gives us the opportunity to select profiles not according to a local maximum stressed area like we do now, but to select a baseline profile design and locally strengthen in a highly stressed area. Finally, if you drastically reduce or want to reduce the environmental impact of the material, and you use renewable natural sources like earth material then you don't need to start an ambitious form finding process. This is also not just do form finding while you need form finding. So it's also depending on the material. And here we have this robotic rammed earth developed. And here is much more important maybe to reduce transportation distances and work on site. And with our robotic technique, we are able to work on site. So by combining ramming and forming in one process, this is the really new of this technology, we have just one process step for both parts of rammed earth. And this is highly economical, but it's also highly economical. And so this is the future also, that we not just focus on one aspect, so environmental impact, both. We also have to be economical, and with the right technologies, both is possible. In summary, I would like to state that digital tools are the drivers to renew the logical form, but the basis is our architectural and engineering creativity. And in the future, we have to find together again as a team and not as separate disciplines. And what is also important, that we respect the rhythm of nature. So 24 hours, 65 days per year. So how nature, we are too fast for the rhythm of nature actually. And it's our responsibility to keep nature in balance. Thank you very much for your attention.